So if for some reason you don't know what a human is, and you type the word human into Google, what might happen is that you come across the Wikipedia page for human, and if you read this page, you'll find out that humans are, quote, great apes characterized by their hairlessness, bipedalism, and high intelligence. And I always think stuff like this is kind of funny because, like, obviously a human wrote this Wikipedia article, but it's still written as if it's from the perspective of, like, an alien observer commenting on the traits that most define us as a species. But aside from that, I think this list of traits is kind of interesting because it seems like it's leaving out, you know, a pretty big part of what makes humans different from other species. Instead of emphasizing the cultural element of humans, this article emphasizes the high intelligence aspect and even goes on to imply, in fact, that it is the cognitive capabilities of humans that, quote, enable them to thrive and adapt in varied environments, develop highly complex tools, and form complex social structures and civilizations. And, you know, obviously there is something to be said for centering this intelligence aspect of our species. Like, snakes can't solve quadratic equations, and North American river otters are probably unaware of how semiconductors work. But at the same time, I think it's worth interrogating this framework a little bit, and specifically the idea that it's our increased cognitive abilities that have allowed us to develop culture, as opposed to the other way around. And you might say, well, duh, like, how could humans have formed culture if we aren't way smarter than all the other animals? And that's an understandable question to ask, but as it would turn out, if you put humans and humans' closest living relative, chimpanzees, up against each other in a number of different cognitive tests, humans don't really do that much better in a lot of the categories, and sometimes do worse. Like, a 2007 study put human toddlers and young chimpanzees up against each other in a number of tests to determine their abilities in 4 different categories: space, quantities, causality, and social learning. And humans only did much better in one of these categories, which you can see. Other tests comparing information processing speeds and working memory for these 2 species show that humans don't really have an advantage in either of these categories, and actually chimpanzees are much better at information processing speeds. And even studies that test a subject's understanding of game theory show similar results. There's a game called Matching Pennies, for instance, that has a very clear optimum play strategy, which I don't want to, like, get into the rules of the game here, you can look it up yourself. But basically, when humans play this game, they oftentimes play worse than chimpanzees. Like, humans are very bad at finding the optimum play strategy, whereas chimpanzees just sort of find it automatically. Playing the game optimally revolves around randomization of your moves, and apparently humans are pretty bad at that, even when it's, like, the most rational thing to do. So what's going on here then? Like, if humans aren't that much smarter than our closest living relatives, then why are we the ones who invented language and culture and complex tools and went to the moon and caused the 6th great mass extinction in the history of our planet? Well, the book The Secret of Our Success by Joseph Heinrich has a pretty interesting answer to that question, which is that culture, rather than raw intelligence, is what allowed our species to be ecologically successful. And specifically this kind of feedback loop between cultural and genetic evolution that has been building and building for hundreds of thousands, if not millions of years, and eventually got to the point where we have, you know, religion and the IRS and Raylo fanfiction. The basic claim in this book is that these 2 types of evolution influence each other, and that you can't really understand the kind of ecological uniqueness of humans without thinking of them both acting together. Anyway, welcome to Generic Entertainment, the channel where I mostly do dumb short skits, but occasionally, for no apparent reason, make fairly lengthy book reviews of books I find somewhat interesting. So without further ado, let's go along. So there's a really weird apparent paradox with humans where it's like, ecologically speaking, we're clearly one of the most successful species ever, definitely the most successful mammals ever. And this is largely as a result of being able to build tools like, you know, deep-sea mining equipment and oil rigs and nuclear weapons. But individually, most of us don't have the know-how for doing any of those things, or really anything that's useful from, like, a traditional evolutionary perspective. For example, you might think you're really clever for being able to solve complex integrals, but let's say, hypothetically, you were dropped off, I don't know, in, like, northern Canada, in Nunavut, in the middle of nowhere, with no food or water and no tools and no know-how of the local environment, and told, good luck, have fun. Do you think you could survive that? Do you think you could survive a winter up there? The answer is probably not, right? And as it would turn out, this isn't just a hypothetical example. In 1845, a guy named Sir John Franklin was leading an expedition to find the Northwest Passage in this part of the world, and his ship got stuck in the ice, and his entire crew had to go out and try to survive in the wilderness, and they all died. But the weird thing is that the local indigenous population had been living there for 30,000 years. There's a group called the Netsilik, an Inuit population. And I apologize if I'm pronouncing that incorrectly. There's going to be some names in this video I'm not sure about the pronunciation for. But this group has no problem living in this area. They're able to build snow houses and make certain kinds of compound bows out of driftwood and hunt seals. And this is an extremely common story when it comes to indigenous populations. Oftentimes they have very specific knowledge of the area in which they live, the local wildlife, and the technologies available to them that allow them to survive in this area, that when explorers come and try to survive off the land in the same way, they're completely unable to do it because they don't have that knowledge. As another example, in Mesoamerica, there's a process called nixtamalization that has been used for 3,000 years or something like that, that has allowed people to eat an entirely corn-based diet without coming down with a horrible disease called pellagra. Basically, corn-based diets lack in an essential vitamin called niacin, and nixtamalization, which is the process of putting lime or ash in the corn mix before cooking it, allows you to get that essential nutrients by breaking down the cell walls of the maize plant and helping to unlock tryptophan, which is an amino acid that's essential for making niacin in the body. Now, does that mean that the Mesoamerican people who invented this process 3,000 years ago knew what was going on? No. They didn't have a good knowledge of amino acids and organic chemistry and all of that. But they didn't need to, because as it would turn out, cultural evolution is really good at helping humans figure things out without having a good causal understanding of why those things necessarily work. Yet another example given in this book is that on Yasawa Islands in Fiji, there are certain taboos around eating certain types of tropical fish, like eels, for instance, especially for breastfeeding and pregnant women. And it's not hard to see why this would be the case, because coral reef fish often carry ciguatera poison, which is a poison that causes some very unpleasant side effects and can occasionally be fatal, and is also, for obvious reasons, very bad for pregnant women to eat. But what's interesting is when anthropologists, including the author of this book, went around on this island asking people why these taboos existed around eating these types of fish during pregnancy, oftentimes people didn't give causal answers. When asked, most of them will just say something like, I don't know, it's the custom. It's the taboo. Does there need to be a reason for it? But this is apparently a really common observation in anthropology, that rituals, taboos, and religious beliefs are basically black box systems. It doesn't matter why they work. It just matters that they do work and that you kind of adhere to them. But anyway, the point I'm trying to get at here is that humans, when it comes to surviving in environments, in their own ecosystems, they have to be taught these rules and taboos by their culture in order to survive. But other animals usually don't have to do that. Like woodpeckers don't need to be taught how to woodpeck, and beavers don't need to be taught how to build dams. In fact, if you take beavers away from their natural habitat, they'll just start building dams out of random household objects automatically, which I think is so adorable. And it's not that other animals don't learn anything from other members of their own species, but usually this learning is restricted to very specific avenues, namely maternal avenues. Animals will learn from their mother, but it's very common for animals not to even know who their father is, yet alone any of their more distant relatives. And this makes humans so weird, because the things we're adapted to do are things that we can't automatically do. Like, you might know that one of the defining traits of humans is that we're adapted for long distance running. We're very good, ostensibly, at chasing down prey over long distances and wearing them down and eventually killing them, sometimes over the course of days. This is how, hunter-gatherers like the Kalahari San survive. We have these hairless bodies that sweat really efficiently, and we have this erect bipedal stance that allows us to run without having our legs jut into our lungs and make it harder to breathe, which is what happens with a lot of quadrupedal animals when they run and why they can't run very long. And yet, despite all these adaptations, I still get gassed after running a mile. Like, what kind of pathetic human being am I? How come I can't do what I'm supposed to be adapted ecologically to do? And in fact, this extends to every useful skill. I can't make fire. I mean, okay, I was a Boy Scout, maybe I can make fire with matches. I can't make fire out of nothing, though. I can't shoot monkeys out of trees with blowguns. I can't find freshwater sources in the desert. I can't do anything that would help me survive in the wild. I'm not Bear Grylls, you know? In fact, all of my skills are catered specifically to the very human context in which I live. They're all skills like literacy, being able to make videos on the internet like this. But when you think about it, maybe that makes a ton of sense. Like maybe the thing humans are fundamentally adapted for more than anything else isn't running, but learning. Maybe the thing we're adapted for is being part of human culture and picking up on skills from other humans so that we can adapt to a wide variety of contexts, much more than any other animal can. And maybe that's why we don't need to develop causal models for adhering to social taboos in order to keep ourselves safe, any more than a beaver needs a causal model for why dams work in order to build a dam. It's just what we do because that's what we do. That's what we're adapted for. So humans are really good at social learning, as that experiment I mentioned at the beginning of this video suggested. Even at very young ages, children are very good at learning from human adults' role models. And this extends not just to things like knowing how to use tools or toys or whatever, but also learning social norms and taboos. For example, in experiments where children were introduced to a type of tool that they've never seen before, and they see an adult using it in a certain way, they'll oftentimes infer that this is the kind of correct way to use the tool. And sometimes, if somebody else comes up and tries to use the tool in an incorrect way, they'll even try to correct that person. Even if they were just introduced to the tool 5 minutes ago and they don't really understand what it is or why it works, if they observe somebody else using it in one way and they trust that person for various reasons, then they'll basically pick up on this as a social norm and try to keep other people in line with this social norm. And yes, this does apply even when the tool is not actually a tool and it's just some kind of nonsense device that doesn't do anything. Even if the role model is just kind of messing around, doing like a random sequence of actions, children will still mimic them and pick up on this as like a social norm. Heinrich refers to this process as one of self-domestication, and he thinks it's basically the reason why we're so relatively altruistic as a species. There have always been a lot of theories about why humans are so relatively altruistic, and some of those theories in the past have revolved around this idea of kin-based reciprocal altruism. So basically this idea that you have a natural genetic urge to show altruism towards people who are directly related to you. And that has kind of, over the years, expanded outwards to encompass many more people than were originally in your kin group. I'm way oversimplifying that. I don't know really much about that theory. But the theory proposed in this book is pretty different. It's this idea that it's actually the enforcing of social norms rather than kin-based altruism that has allowed humans all over the world to kind of adhere to certain rules when interacting with other humans, even if it's somebody you're never going to speak to again. For example, there's this kind of ridiculously simple psychological study where there are two players put into a game of sorts, where one player is kind of the giver and one player is the receiver. And basically the way the game works is that there are $100 on the table, and the giver can choose to give any amount of that money to the other person, the receiver, and take home whatever is left. But the receiver has the ability to reject their offer. And if that happens, then neither of them walk away with any money. Now, the weird thing is, if you're purely self-interested, then the optimal strategy as the receiver to maximize your earnings in this game would be to accept any offer above $0. Even if the other player just offers you $1, you should accept that offer because otherwise you're getting $0. But that's not what humans do. Very often, if the receiver thinks that the offered amount is too low, they will reject that offer outright and be totally happy with walking away with zero money because they see the other person as having violated some kind of altruistic social norm. And this holds true even if the two players don't interact at all, if they're in separate rooms. So this is kind of weird, right? Especially when you compare it to chimpanzees who live in very small bands and who express great hostility to anyone outside of their very small band. It's very weird when you consider that humans have this social norm of like being nice to people. So like, why? How did we get here? How did this happen? And if it really was cultural evolution driving this process the whole time, do we have evidence of that? Do we have evidence of culture directly affecting our genes and our psychology in such profound ways as to completely change the way we interact with each other worldwide as a species? Well, as it would turn out, yeah, we kind of do. So there's a certain gene in the human genome called ADH1B, which codes for the enzymes that help break down alcohol in the liver. And, you know, like this is what ensures that we don't literally die every time we drink alcohol. But there's a weird variant of this gene that cropped up around like 7,000 to 10,000 years ago. And this variant of ADH1B codes for enzymes that break down alcohol way more efficiently than normal. But this improved efficiency comes at a cost, because while these enzymes are metabolizing the alcohol, it causes you to feel nauseous and weak, and it comes with a whole host of other unpleasant symptoms. The gist of it is that having this gene means that you are less likely to get drunk, because drinking alcohol is an inherently more unpleasant experience. Now, what's interesting about this gene, though, is that it's like very unevenly distributed around the world. If you look at a map of where it's distributed, it's largely concentrated in like a couple regions, especially Southeast China. And if you look at the archaeological history of that region, there is apparently evidence of rice wine fermentation in that area around the same time that this gene started to take on prevalence. And so, you know, you might say, obviously, like, correlation doesn't equal causation and all that, but there's a story here that you could tell, which goes something like humans invented agriculture in that part of the world, and they discovered rice wine fermentation because they were domesticating rice at that time. And as a result of that, people started drinking more. And then this ADH1B variant popped up in the population. And for obvious reasons, it was kind of beneficial to have this gene, because it meant you were less likely to get drunk. And so you probably had higher reproductive success, since you were less likely to die of alcohol poisoning or whatever. And that process kind of built and built so that now in that part of the world there's like a 99% prevalence of that gene in the population. And so, you know, if this story is true, the implication is that something that humans invented, a technology that humans invented, agriculture, and specifically alcohol, the fermentation of rice wine, caused a change in the human genome. And this isn't the only example of something like this happening. Like, this also explains why some humans are lactose intolerant and others aren't. The book gets into all these examples, but I don't really have time for that in this review, which is already probably going to be fairly long. But these examples, I think, are particularly interesting because they show that this process of cultural evolution affecting genetic evolution is something that's still ongoing. Now, we don't really have examples of how more recent innovations than the agricultural revolution have affected the genome. You would imagine that maybe in like 10,000 years, we'll start to see how the Industrial Revolution has changed us in some pretty profound ways, but we're not quite there yet. Enough time hasn't passed yet. Like, evolution is really, really, really slow. But fortunately, we can point to older examples of culture-gene coevolution and see that this process has been going on for quite a long time. Like, for example, have you ever been to a zoo and seen like a gorilla or a chimpanzee just like kind of munching on leaves, and ever thought to yourself, you know, why can't I do that? Why can't I just eat leaves all the time? Well, the reason is because humans invented processed foods. We basically externalized the process of digestion, so that now we are almost entirely reliant on eating processed foods. Like, there are very, very few foods that we can really eat unprocessed in a healthy way. And as a result, our guts have shrunk, our stomachs are like much less complex than those of other apes. And yeah, we can't eat leaves all the time, basically. This also explains why chimps are so like insanely jacked. I mean, have you seen a hairless chimp? They look like this, and I look like this, okay? There's like a pretty huge difference there. Well, as it would turn out, culture also stole our muscles. Like, we need these big brains in order to store all this cultural information around us and, you know, form like complex social structures. And that takes a lot of energy. Like, brains take so much energy. They're like the Adobe Premiere of organs. And as a result, we basically traded being jacked for being smart. And even our ability to run long distances and hunt prey is explained by cultural evolution. Because, like, if we couldn't invent water containers, and if we couldn't find sources of water in the desert while we were running, we would never be able to do that. Even with our efficient sweating and our upright posture, we wouldn't be able to hunt animals for days if we didn't have a way of finding water. Most animals can't carry water with them wherever they go, but we invented, like, you know, drinking pouches and stuff like that. So this stuff is all just so insanely cool. But what's interesting is that cultural evolution doesn't just act on genes. It also affects our psychology over much shorter time spans without even needing to affect our genes. And that is a whole topic of its own. So I don't really like spicy food that much, and if I had to give a reason why, I would say something like eating spicy food, like really spicy food, is an objectively painful experience. Like, it literally causes a chemical reaction that makes it feel like your tongue is on fire. Why would you willingly do that to yourself? But a lot of people don't think that way at all, and even I am starting to develop a taste for spicy food, which is definitely being helped by the fact that I'm in India right now. And what's interesting is if you map out places that have like the spiciest cuisine and the least spicy cuisine, you can see some pretty clear trends about where people like spicy food. Like, cuisines that come from regions that are closer to the equator, like India, seem to be spicier in general than cuisines that come from regions that are farther away, like Germany or Denmark. And as it would turn out, there is a reason why this is the case. For one thing, chili peppers and other spices have antimicrobial properties. And the second thing is that hotter climates tend to have much more disease than cooler climates. And so it seems like there would be genuine strong incentives for cultures living in hotter environments to want to eat spicy food to protect themselves against disease, at least somewhat. And yeah, that might be exactly what happened. Hey guys, editing Nathaniel here. I just wanted to add that while doing research for this review, I stumbled upon this paper that claims that there isn't very much evidence for a correlation between climate and the average spiciness levels of food. And while I couldn't read the paper because it's locked behind a paywall, of course, this does seem to track with everything I've seen. Like, I couldn't find very good data for this claim or any studies that strongly support the conclusion this book comes to. Now, I don't think that detracts from the larger point of this section of the book, which is that culture can genuinely change your mind about things and influence the way you think. I don't think it's a very controversial claim to say that the culture in which you're born plays a large role in influencing what foods you like to eat. But it is something to keep in mind about this book, that some of the anecdotal pieces of evidence or theories might not be super well backed up or are conjecture. And most of the time, I think the author does a good job of showing when this is the case. Anyway, I just wanted to clarify that. Back to what I was talking about earlier. The same could probably be said for a lot of acquired tastes. Like, I think of this video I saw on the internet the other day of a camel eating a lemon and just like instantly spitting it out in disgust. And I thought that was interesting because humans love lemons. We put lemons in lemonade and lemon meringue pie. But lemons themselves, kind of like chili peppers, are like inherently disgusting. Why is that? Well, maybe it's because of culture. We have cultures that like lemons and like chili peppers, and we have kind of developed a taste for them. We've literally had our brains changed by the cultures we live in to like stuff that we wouldn't otherwise have liked. And to take this even further, this also helps explain the placebo effect. This effect where, like, medicine only works sometimes or works more effectively if you believe it's going to work. The placebo effect is one of those things that's just like so weird to me. Like, it seems like the kind of lazy cop-out a fantasy writer would come up with to explain how a magic system works. It's like, oh, you have to believe in magic in order for magic to work, you know? But like, it's a phenomenon that's very well studied and very well attested for, and culture helps to explain that. Like, if a trustworthy looking doctor with a degree from a prestigious university comes up to me and gives me a medicine, I'm probably likely to believe them and take the medicine and think it's going to help me get better. In other words, the placebo effect might not really work without culture. And so at this point, maybe you're like, okay, that's all really interesting, but like, why? Why did this happen specifically to humans? Why did we invent culture, basically? After all, other species seem to have certain types of culture, like apparently orcas like to wear hats sometimes, but why were we the ones to invent cities and the concept of a nation and bureaucracy? In The Secret of Our Success, Heinrich constantly refers to crossing the Rubicon, which is basically the way he describes how at some point in the evolution of our species, we crossed a certain point where cultural evolution overtook biological evolution as the dominant force shaping our brains and our bodies. There's a basic feedback loop here, where it's like having a lot of cultural information requires a bigger brain to keep track of all that cultural information, right? But having a bigger brain means that there is the potential for more cultural information to exist, which means that we need bigger brain to keep track of all that information, and so on and so on. You know, it's a feedback loop. But there's a problem here. How do we get enough cultural information in the first place to actually start this feedback loop? Like, in order to have all that information in existence, we have to have big brains. It's like a chicken and the egg problem, you know? Well, this is what the author of the book refers to as the startup problem, and he thinks this is largely why we are the only species to cross the Rubicon so far. So there's kind of two answers that the book gives to this question, two pathways, so to speak. One of them is related to terrestriality, and the other is related to sociality and care. Basically, here's the very short form of it. It's very hard to acquire culture when you're living in trees. You know, if you invent tools, the tools are more likely to fall to the ground where you can't use them. Chimps, after all, use tools, but they don't usually keep the tools around. Also, up in the trees, you're kind of safe from predators, and you're more separated from other members of your species because there's like branches in the way and stuff. But when our ancestors came down from the trees like 5 million or so years ago, they started to form bigger groups, right? To keep themselves more safe from predators. That's a common survival strategy. Put yourselves into large groups to increase your own individual chance of survival. And also there's like more stuff to use on the ground to make tools with, right? This was a pretty like huge change in our lineage. And the fact that apes themselves are already pretty intelligent, like we can imagine that the common ancestor between humans and chimpanzees was of a similar level to intelligence of chimpanzees, which means they were using tools, they had some social structures, right? They had all of this stuff. They just hadn't yet gotten to the accumulation point, the cultural accumulation point. So this helps start getting that feedback loop going, right? You get bigger groups, you have more tools to use, and so there's more cultural information to acquire, and so you have to get bigger brains and yada, yada, yada. But there's also the other pathway, the sociality care pathway, which is pretty interesting in its own way. Basically, aside from terrestriality, there might have been another interesting change in our lineage around this time, which is the evolution of dyadic relationships, like monogamous relationships. And there are several reasons why this might have evolved, like it helps decrease male-male competition and, you know, lowers testosterone levels, which leads to like less violence and all of that, which is all like good for survival in a group setting. But basically the weird kind of like unexpected side effect of monogamous pair bonding for life is that now children, young members of the species, have a greater knowledge of who their relatives are. And that's like really weird to think about because most animals have no idea who their own father is, yet alone who their expanded relatives are. But when you have animals living in a pair bonding situation where both parents are helping to take care of the young, then you have like more opportunities for learning from people, right? You have a greater bond to more members of your species. And this also means that more people are going to help care for the young. Like it's not just going to be the mother's job. She's also going to get the help of relatives and even completely unrelated people, like members of the community. Studies show that this is very common in human hunter-gatherer societies, but not at all common among chimpanzees. Like this is almost non-existent among chimpanzees. And so as a result of this, as a result of there being more investment in the children, it's possible for childhoods to become longer. And that's important because that means that children now have more time to acquire information. And it means that they can be born in a more underdeveloped state, right? Unlike a lot of other animals that are born almost already walking, so that they can acquire a lot of the kind of information they need for survival after birth rather than it being built in. So obviously, like, you can't empirically test this stuff. You know, this is just a story. We don't really know what happens when our ancestors came down from the trees 5 million years ago, and we never really will know. But as long as we don't place undue confidence in any one narrative in particular, I think a story like this helps explain a little bit why we are the only species to cross the Rubicon, so to speak. It seems like a lot of different factors have to come together to get that feedback loop starting, to overcome the startup problem. And maybe we just got really lucky. After all, this is how evolution works. It doesn't walk, it stumbles its way like a drunkard. And when it crossed the Rubicon, it probably meandered its way into it almost without realizing what it was doing, almost drowned a few times on its way over, and then kind of stumbled onto the opposite shore, barely alive. But we're here now, we made it, and now I get to use this cool thing called language and this cool thing called the internet to talk to all of you guys about this. So that's kind of cool, I think. So like, wow, what am I gonna do with all this information now? What am I gonna do with all this new cool stuff I've learned? Honestly, I don't know. I think one benefit I get out of reading books like this is that it always gives me a newfound appreciation for humans. It's sometimes easy to forget how incredibly cool humans are, but when you read a lot of anthropology-related stuff like this, you start to notice how your own behaviors are dictated by people around you. Like after reading this book, I've started to notice how I unconsciously imitate the actions of other people sometimes, almost as if other people give me permission to act in a certain way. And I've even noticed how that sometimes happens the other way around, like people can sometimes imitate me without even realizing it. Like if you've ever been at a party or a meeting or whatever, and it's getting late and everybody's getting kind of bored, and then one person sort of stands up and says, you know, I'm heading out now, and then that kind of gives permission for everybody else to do the same thing within very short order. If you've been in that situation, then you might understand a little bit how humans automatically mimic each other, how we sort of like unconsciously give each other permission to do different things and behave in certain ways. But I also think about how the ideas in this book have tied into other ideas in psychology I've read about. Like for example, I've been thinking a little bit about moral licensing and how that can tie into this framework. Moral licensing is this weird phenomenon where like people will do one good thing and then after that sort of give themselves license to not do a good thing in the future or even to do a bad thing. Like if you give money to a homeless person, you might give yourself license to do something, I don't know, indulgent later on just because you feel like a really good person after that. It seems to me almost like this phenomenon can maybe be explained as like a balancing between the social norms and obligations we inherit from cultural evolution and our kind of own self-interest from biological evolution. Like we have to put on a show of behaving altruistically, but we also think that that gives us leave to do other things for our own self-interest. Like we're constantly playing this tug of war in our heads between people around us and ourselves. I don't know, this wasn't mentioned in the book at all. These are just like random thoughts I have after reading all this. But anyway, one of the main reasons I read books like this is to give myself ideas for writing, and hoo boy, did I get a lot from this book. I've been thinking for a while now that there's like a deficit of fiction inspired by anthropology, and that's something I really want to like explore in my own stories and my own world building and writing. In learning about the different ways of thinking around the world and different kinship systems and taboos and all of this really just kind of gets your brain churning, and once it starts, it can't really stop. Anyway, there's a whole lot of stuff in this book I didn't touch on, like a whole bunch of other interesting topics and even whole chapters that I didn't even mention. This is a fairly decent sized book. It's like 500 pages. As you're probably noticing, in this review, I'm trying to give like an overview of the book itself so that like if you're not interested in reading it, you don't have to. You can sort of get the breakdown here. I think there's a real deficit of nonfiction book reviews on YouTube, especially in-depth breakdowns, and that's something I kind of want to do sometimes at least. But with that being said, there is a whole bunch of other stuff in this book that I didn't mention, so if you were interested in reading it, I think it would be worth your while. It's not super technical, maybe occasionally a little bit technical, but definitely accessible to, like, I think anyone. I mean, I read it, so that should tell you something. I'm not an anthropologist or whatever. Anyway, I think humans and anthropology are really cool, and I hope that other people think the same way and that some of you all find this video at least somewhat interesting. This is only the second time I've done a nonfiction review like this, and it's always a bit of a gamble considering that it's totally, completely different from the other stuff I do on my channel, so any support you give the video would be greatly appreciated. But anyway, thank you so much for watching. Have a great rest of your day, and I am gonna go get some dinner, so see you.